our next speaker is Isabella Kukor, and she's also a graduate student. She's working on her PhD at Colorado State in the Department of Animal Sciences. And she's been working and collecting for the last several years heart scores and performance data to help us really identify the genetic influence of bovine congestive heart failure. And in doing so, she's going to talk a little bit about the differences between beef on beef and beef on dairy in terms of what she's doing today. With that, Isabella.
Thank you, Dr. Doyle. Perfect. So if you're here for Troy's presentation, like I said, it's kind of like the first day of class. You're in the wrong speaker class, so I won't take offense if you want to go somewhere else, but we did trap you into a heart score comparison on finished beef and beef on dairy animals and looking at heart failure within those. So a few years ago, I got the privilege as a master's student to talk at BIF. And since then, we've collected a lot of data on heart scores, a lot more on different types of animals. So just to give a quick recap of what that looks like, in beef cattle at moderate to low altitude, we found that scores of 3, so these are hearts that have moderate remodeling, which we'll kind of talk about the grading system here in a few slides, tend to be those animals that have more weight on them, have those higher carcass weights, and these are typically considered our animals that are going to be genetically superior in carcass and performance traits. When we look at dairy cattle specifically, we often see them die due to heart failure early in the feeding period compared to beef, but beef cattle tend to still have a higher risk of heart failure in comparison to their dairy and beef on dairy or progeny comparisons. And we have seen that in some past studies here in the last year, that heart scores or worse heart scores were positively correlated with the percentage of Angus ancestry observed on a genomic breed analysis in a previous study. And so heart scoring has come a long way of what we know, where we started from. For those not familiar, this picture up here was taken by Dr. Holt. He is the guy kind of behind a lot of the PAP research out here, as well as the heart scoring grading system. So this is from a calf actually that passed away. He did a necropsy. But just looking at this heart, and we'll look at later is some normal hearts as well, but there's just kind of like a round circle of a flat heart essentially. And these are those animals that they'll just kind of peel over and be dead in a matter of seconds, and there's nothing you can do to help. So this can really happen at any age. And even though it's less likely at a younger age, it's definitely hard to determine which animals are at risk. So when we look at feedlot heart disease, this is different than mountain disease or altitude disease, because this is affecting cattle at those moderate to low altitudes. So we no longer have kind of that hypoxic altitude problem here. So us coming from Colorado, we can breathe a lot better already, which is just a good example. And if you go to Colorado and you go up the stairs, don't feel bad if you are out of breath. It might be because you're out of shape, but it also might be because of the altitude. And it's a real thing. It's harder to breathe when you're up at altitude. So these animals, they don't have that altitude problem. So we're kind of looking at what's the direct cause, what's kind of happening with these animals. And there is some research done on these different cattle breeds, but there's not really a known origin or a breed specific origin on the disease. And these slides here show a cross section. The top is going to be a normal pulmonary artery, and then the bottom is going to be an abnormal artery. So if you see that space, the white space in the middle is going to be where the blood's flowing. So we can see as that shrinks and kind of constricts down, it's going to be harder for the heart to keep up with that type of pressure in the system. And this can't be reversed once it starts. So once that begins to narrow, we're going to see how you can't really go backwards from that. So the progression all starts with pulmonary hypertension. This is very similar to kind of having high blood pressure in the pulmonary artery. So in cattle and in people as well, we see that the pulmonary artery there's a detection of less oxygen. We have alveolar hypoxia, and in return, since the body wants to be in homeostasis, the pulmonary artery is going to constrict to bring more blood to those areas of low oxygen. In return, when we have that constriction, we need more muscling to basically push more blood against that force. So we have smooth muscle growing not only in the pulmonary artery, but in the right side of the ventricle, which is going to be that blue section of the heart down there. With that, everything kind of begins to narrow. Even the space within the right ventricle starts to get smaller. And all in all, this causes it harder, or it causes it to be more difficult for blood to pass through. So pulmonary arterial pressure increases, and this kind of keeps going until the heart muscles can no longer constrict because they've built up so much that they just start giving out, and all of a sudden that space opens up and that animal will eventually kind of die on the spot there. So as I mentioned, Dr. Holt, he's kind of been behind all of our PAP studies. You may have had the pleasure of meeting him in that, but he's done so many PAP studies around the nation and world that he began to follow some of these animals to the harvest and start recording what this heart looks like in these high PAP animals. And he created this visual grading system that goes from a score of 1 to 5. 1 is going to be a normal heart. 2 is going to be mild remodeling of the heart, but both are considered our normal, indicated by the green squares. 3, when we start looking at the heart, we're mainly focusing, I think the easiest would be to focus on the right side. There you begin to kind of see a shelving and a deviation away from that normal kind of heart shape that we like to see. We begin to look at scores of 4. That's going to be more severe remodeling. So now the right ventricle is almost or is bigger than the left side. And we also see kind of like a double apex kind of shape forming. And then a score of 5 is going to be that flat, flaccid heart that has no muscle tone. And a lot of the times when we look at research, heart scores of 5 aren't as common. These animals tend to die before they even make it to the harvest state. So unless struggling animals can be identified, if you did a necropsy, this is kind of what you would see inside the animal. So what does this look like specifically in just our beef cattle sector? So like I mentioned, this can happen at any type of operation, any age, and any level of altitude. So according to the USDA, the Western plains of the United States and Canada tend to be the most at risk because we do also have that altitude factor and can cost a single operation $250,000 in just loss. And in some operations, we have to also recognize that heart failure might be more significant than even things like bovine respiratory disease. So previously, we've seen a prevalence rate of around 30% of the population will be affected by some sort of heart remodeling. But even if we can identify those animals, it's very difficult to manage and very difficult to outline what's happening with that animal because it can look like so many other things that we see on our operations. Some of those even looking like bovine respiratory disease, or some can even argue kind of what came first, the heart failure or the BRD. It's kind of a difficult question to answer, but they all kind of are interconnected on what's happening within the cattle. So what about in just the dairy sector? So it is pretty difficult to determine the prevalence. In my study done at CSU, we had about 11% incidence rate in some beef on dairy animals in the past. But as a whole, there's not a lot of studies done on what heart failure looks like in dairy cattle in a dairy management setting. So just in milking cows and things along those lines. And that kind of concludes us to think that perhaps right-sided heart failure either isn't a problem for that industry, or there are other problems that they're facing that tend to receive a little bit more emphasis. But it's also important to note that when we're talking about types of cattle, they're very different, almost very different animals, even though they're all cows. They're not going to be managed the same the way that a beef producer is. They're not going to just jump into dairy producing and vice versa. And so they're almost treated as two different animals. And now we have that kind of overlap with our beef on dairy animals. So for those, maybe just to refresh everyone, why we even started doing this and bringing this together. It just ended up being an advantageous breeding method or management tool for dairy producers. So dairy producers could use beef semen on milking cows. Those progeny would essentially make up about 20% of our fed cattle. And on top of that, they tend to outperform just Holstein steers or Holstein heifers potentially going to slaughter there in carcass and performance qualities. And typically the producer is going to get more money per head as well as an outcome. But we really don't know anything about what right-sided heart failure is what is happening to those animals in terms of right-sided heart failure, if there is really a prevalence, and what that kind of combination looks like. So the objective of this study was to examine the prevalence of heart remodeling in beef and dairy cattle breeds and to investigate whether there are some breeds that had a higher prevalence in heart remodeling. So in our study here, I had a cohort of beef cattle and then a cohort of beef on dairy cattle. The beef cattle were raised at a moderate elevation in the panhandle of Texas, and it was comprised of two main beef breeds, Angus and Simmental. They were fed on feed 95 to 146 days, and there were 831 head of cattle in that cohort. In our dairy crossed animals, they were also at moderate elevation, but in western Kansas, and was comprised of mixes of Holstein Jersey, Angus, and Simmental. So different combinations of those four breeds existed. They were on feed for a much longer time, and there was 476 of them. All of the animals here, we had a mix of heifers and steers. They were collected between the years of 2020 and 2023. And overall, we had about 1,300 animals in the whole study. So just to kind of break down some of the breeds that we had, these were all the possible combinations of breeds that I was able to identify in this cohort of all the animals. Above the yellow line shows the beef breeds, and then below the yellow line shows our dairy and beef crosses. What we have here are some box plots. And so on the x-axis, it tells you what the heart score was. So recalling that a heart score of 1 and 2 are considered normal. Anything above a 3 is considered abnormal and an animal at risk for heart failure. And from there, I only organize these by the mean of what those animals scored. So we can see just by default, our beef breeds tend to have about 50% of their animals tend to fall between 2 and 3. So a majority of the cohort of those specific breeds fall in that range of going from a 2 score to an at-risk score of 3, or living in a score of 3 at the when they were harvested. Now, when we look at the crosses of dairy breeds in there, we see that those scores, the distribution tends to be a lot lower. So between a 1 and 2, which is an arbitrary kind of change, a very mild change, and is still, like I said, considered a healthy heart. So we don't quite have that tendency of the major distribution being bad heart scores within these dairy crossbreeds, and potentially showing that maybe the type of animal this is tends to be more at risk if it's predominantly beef breeds or only beef breeds. Then incorporating the dairy animals might not have that much of a risk. And also good to note that it wasn't unheard of for these dairy crosses to have abnormal heart scores, because the black dots represent outliers in the data set. So there were some individuals that did have bad heart scores, and were identified underneath that breed composition. Now, when we look at the distribution of the cohorts in general, we have a histogram showing scores of 1 through 5, and the blue bars represent our dairy cross, and then our red bars represent the beef breeds. And we see this heavy distribution of 2s when we just look at the red bars. So it tends to peak at 2, and then we have more scores of 3, and then 4, and not as many 1s. Whereas our dairy tend to have more scores of 1 and 2s, and then drops down severely, almost a third of what we see in the beef cattle. And like I said before, we don't usually see the scores of 5. I believe there is one score of 5. It's just really tiny and you can't see it on this chart. But overall, the prevalence in the cohort of dairy crossed animals was 16%. And then in the beef cattle was about 29%. So we went ahead and looked at the percentages of each of the breeds that I had and were identifiable. And just to see if there was some sort of trend going on within each increase of 1 unit of breed in an animal, how that would affect the heart score. And what I really want to highlight here is when we look at our dairy breeds, their coefficients are much larger, even though they're all negative within our estimates. They're much larger, showcasing that having a dairy breed or having a percentage of dairy does decrease at a significant rate the heart score overall. And so by adding more of the dairy breeds, we're going to see less, on average, less heart score or a lower heart score than we would with adding breeds, other beef breeds, which in this estimate here don't really make too much of a difference. Or they are not very different from 0 or no difference. So just to kind of look at what the probability is here, when we look at just normal heart scores, we can see that dispersion a little bit more. So we have our green tread line representing Holstein, our blue one representing Jersey, and then our red one representing Simmental, and these are all compared to % Angus. So as we move from 0% Angus, the tread lines kind of follow what that trade-off would be. And what we really want to focus on is seeing kind of the disparity between dairy breeds and beef breeds. And that gets us more into conversations away from what breed composition specific on the heart scores and more about what type of animal are we breeding. Are we looking at the beef breeds where they're going to be heftier, have more weight, or are we going to have a little bit of that dairy, which might actually kind of lean them out, less carcass weights. And as they kind of decrease in weight, because that's probably what we're going to get with adding dairy into our animals, you're going to have a higher probability of having lower heart scores, which is good. And if you have beef breeds, that might not change too much depending on what beef breed you put in there. It might really not decrease your probability of reducing the risk of heart scores. And so going from there, to wrap it up, we had an increase of, or adding Jersey or Holstein breeds resulted in higher probability of lower heart scores. And we found the incidence in beef breeds were found to be associated with some to little differences in the improvement of heart scores, alluding to potential breeding advantages for those beef on dairy producers in reducing and mitigating the risk, but not much in terms of breed specific differences within, more of a type difference conversation when we talk about heart scoring. And with that, I would like to acknowledge everyone that made this possible for us and all of our sponsors and for our grant that we received for this project. And with that, I'll take any questions anyone may have.